and welcome. Today, we have an exciting tutorial where we'll be guided through the fascinating world of binary numbers. We're your hosts, Khayzee and Daniela, and joining me are our experts in binary arithmetic, Ahleah, Ilysse, Cheng, and Nicole. Whether you're a computer science enthusiast, a student, or just someone curious about the inner workings of computers, understanding binary is a key skill. In this tutorial, we'll cover the basics of binary, how it works, and guide you through performing addition, subtraction, multiplication, and division with binary numbers. Let's start with the basics. Binary is a numeral system that uses only two digits, 0 and 1. This is in contrast to the decimal system we commonly use, which has 10 digits, 0 to 9. In binary, each digit is called a bit and represent powers of 2. For example, the rightmost bit represents 2 raised to the power of 0, which is equal to 1. The next bit to the left represents 2 raised to the power of 1, which is equal to 2, and so on. Now let's start computing for addition in binary numbers. Let's break it down to the rules. 0 plus 0 equals 0. 0 plus 1 equals 1. 1 plus 0 is equals to 1. 1 plus 1 equals to 0 with a carry of 1. So now in binary addition, you follow similar rules as in decimal addition. Start from the rightmost bit, add the corresponding bits, and carry over if the sum is 2. That's where 1 plus 1 starts. The sum at each position is either 0, 1, or 2. Write down the result and carry over if needed, moving left until all bits are added. As you can see here, we have our first given in addition of binary. First, you add the rightmost bits, which are 1 and 0, the sum is 1. Add the next bits, which are 1 and 1. From the second position, the sum is 1, 0. You write down 0 and carry 1 to the next column. Add the next bits, including the carry, which are 1 and 0, and the carry from the previous step. The sum is 1, 0, 0. Write down the 0 and carry the 1 to the next column. Now you add the last bits, including the carry, which are 0, 0, and the carry from the previous step. The sum is 1, 0, 0, 1. And that's where you get your answer, 1, 0, 0, 1. Now you must do the checking to see if your answer is correct. Now to do the checking, you must first write down the binary number and assign powers of 2 to each bit position, starting from the right and increasing by 1 to the left. So as you can see here, we have 1, 2, 4, 8, 16, 32, 64, 128, and so on. They are powers of 2. You multiply each bit by its corresponding power of 2 and you calculate the results. Remember, 1 stands for true, 0 is for false. If the binary bit is under 0, it means it's false. You don't have to calculate that. It corresponds to 8 and 1. Those are the only true values and you must only count those. So we have 8 plus 1, which is equals to 9. We can also confirm this by checking the original values of the equation. 0, 1, 1, 1, which is equal to 4 plus 2 plus 1 is equal to 7, while 0, 0, 1, 0 is equals to 2. It's 7 plus 2, which is equals to 9. Here is our next given, 0, 0, 1, 1, 1 plus 1, 0, 1, 0, 1. Okay, first you must add 1 plus 1 equals, as we all know, 0, and then you carry over the 1. Next, we have 1 plus 1 plus 0. Copy 0, and then you carry over 1. Now, here is a unique one, 1 plus 1 plus 1. It is still equals to 1, and then you must carry over another 1. Add the bits along with the carry. 1 plus 0 is just equal to 1, no carry or anything. And then lastly, write down the last sum, which is 0 plus 1, and it is 1. The sum in total is 1, 1, 1, 0, 0. Now let us do the checking. As always, make sure to start with the rightmost bit. Let's check our sum. 0, 0, 1, 1, 1, 16 plus 8, that would be 6 plus 8 equals 14. 1 plus 1 would be 2. and then you add 4. 24 plus 4 equals to 28. That is the decimal number version of our sum. In the original equation, 00111 is equal to 7 and 10101 is equal to 21. As you can see, 21 plus 7 is equals to 28. Now here is a third equation. 1011101 plus 1000000. So first you may add the rightmost bits first. 1 plus 0, we all know that is equals to 1. 0 plus 0 is equals to 0. To the next bit, 1 plus 0 equals 1. And then the next bit, once again, 1 plus 0 equals 1. And then the next bit, 1 plus 0 equals 1. And then to the next bit, 0 plus 1 equals 1. And there we have 0 plus 0, which is equals to 0. And then lastly, to the last column, 1 plus 1, you write down 0. And then you still, there will be no carrying since this is the last column. You just copy 1 and then 0. Now let's convert the binary result 100111101 to decimal to verify if it matches the expected answer, which is 157. So here we have 128 plus 16, that would be 14. 1 plus 2 plus 1 equals 4, and then bring down 1. And then 144 plus 8, that would be 12. That would be 152. 152 plus 4, it is 156. And then lastly, plus 1, 157. To fully confirm this answer, you may convert the original equation to decimal. So 1011101 is equals to 93, and 1000000 is equals to 64. If you add those both together, you get the sum 157. Now here we are in our last given, 1001100 plus 1100101. Now of course, 0 plus 1 is 1, and then we have 0 plus 0, which is equals to 0. And then there is 1 plus 1, which is, you must write down 0, and then you carry the 1. And then you add 1 plus 0 and the previous carry, which is 1. So that makes 1 plus 0 equals 1, and 1 plus 1 equals, write down 0, and then you carry the 1. In the next column, we have 0 plus 0 plus the previous carry, which is 1, which is basically 1 plus 0 plus 0, and that contributes to 1 only. We have a 0 plus 1 here, and that is obviously equals to 1. And then we lastly have in the last column 1 plus 1, which is equals to, write down 0, and since there are no more columns left, you write down 1 still, so that will become 1 and 0. Now let's convert the binary result 10110001 to decimal to verify if it matches the expected answer 177. So that is 128 plus 32 and plus 16 and then plus 1. So 128 plus 32 is 160, plus 16, that would become 176, and lastly plus 1, that would be 177. To check the further credibility of the equation, we may convert the original of these values to a decimal. So 1001100 is equals to 76, and 1100101, that is equals to 101. So that 101 plus 76, 6 plus 1 is 7, 0 plus 7 is 7, and then bring down 1, that is equals to 177. Now that we've covered binary addition, let's seamlessly transition to the subtraction of binary numbers. Now, subtraction in binary follows a similar process as subtraction in decimal. just like addition, multiplication, and division, but with some unique considerations. Now, here are the rules of subtraction. 0 minus 0 equals 0, 1 minus 0 equals 1, 1 minus 1 equals 0, and 0 minus 1 is equal to 1, and that is because you borrow from the next column. In binary subtraction, you follow similar rules as in decimal subtraction. For example, in addition, 1 plus 1 plus 1 equals 3 in base 10, and 1 plus 1 plus 1 equals 1 in binary number system. When you add and subtract binary numbers, you will need to be careful when borrowing as these will take place more often. On another note, when you subtract several columns of binary digits, you must take into account the borrowing. When 1 is to be subtracted from 0, or which is 0 minus 1, the result is 1, where 1 is borrowed from the next highest order bit or digit. To start off, we have our binary arithmetic expert Kathleen Cheng handling the operation of subtraction, where we'll be subtracting 111 from 11111. Let us apply the rules of binary subtraction with this easy equation. So 1 minus 1 equals 0, 1 minus 1 equals 0, and to the next column 1 minus 1 equals 0, the next column 1 minus 1 equals 0, the second to the last column 1 minus 1 equals 0, and 1 minus nothing, you just bring down 1. Now we may start checking for the binary numbers. Let us start at the top. 1 1 1 1 1 1. As you can see, everything is true, and that reaches until 32 only, and if you add them all, you'll get 63. Now let us accommodate for the second one, which are 5 ones, which makes it true for everything until 16. So if you add them all, then you would get 31. Now we have the decimal version. This would be basically saying 63 minus 31. That would be 3 minus 1, that would be 2. And 6 minus 3, that would be 3. Now let's see if the result is correct. We will put 5 zeros under the powers of 2, and then 1 in the sixth one, and which is 32. Verifying that the equation is indeed correct for decimal and binary. Now we will have the second given, which is 111 subtracted from 10101. Okay, let's apply our knowledge from the rules of subtraction once again. 1 minus 1 equals 0, and 1 minus 0 equals just 1. 1 minus 1 equals to 0, and 1 minus 0 equals to 1. 1 minus 1 equals 0, and 1 minus nothing is simply 1. Now let's do the checking. 11111, as we all know earlier, is still 63, and 10101 is equals to 21. Now, once again, this would be like 63 minus 21, 3 minus 1 equals 2, and 6 minus 2 equals 42. Now, let us check the result if it is really accurate. That would be 0, 1, 0, 1, 0, 1, starting from the right, and you write them down at the basis of 2. That would be equal to 32 plus 8 plus 2, which is, yes, 42. Now we are on to our third given, 101010 minus 10101. This is unique, different from the previous ones, as this will include borrowing. Now, first off, subtract the rightmost bits. Since 0 is less than 1, we need to borrow from the next bit. Borrow 1 from the next bit, making it 0, and the current bit becomes 2. 1 borrowed plus 0 in the original. Subtract again, 2 minus 1 equals 1, and write down the result below the line. Now, since it is cancelled, it will be 0, so 0 minus 0 equals 0. And you can see here, another cannot be, so you must borrow from the next bit, making it 0, and the current bit becomes 2 when borrowed, and 0 original. Subtract again, 2 minus 1 equals 1. So since it is cancelled, 0 minus 0 is equals to 0 again. And then 0 minus 1 is another cannot be, so you must borrow, making it 0, and then the original bit 2 minus 1 equals 1. Here we have the answer, 10101. Now we must do the checking. The minuend, which is 101010, the top one, it is equals to 42. And the subtrahend, the number we subtract, 10101, it is equals to, that will be 21. So that will form the decimal equation 42 minus 21. We know that 2 minus 1 is obviously 1, and 4 minus 2 is equal to 21. And since, as you can see, the subtrahend is the same as the result, we know that it is correct. Now here we are at our last equation, 110110 minus 110011. Now let us use our full knowledge from the previous equations to answer this given. 0 minus 1, well, 0 is less than 1, so you must borrow from the next digit. That becomes 2 minus 1, and that is 1. Since it's 0, you must borrow again, so that becomes 2 minus 1, and that's 0 is 0 minus 0 is 0, 0 minus 0 is 0, 1 minus 1 equals 0, 1 minus 1 is 0, and that is it. Let us do the checking to see if our answer is truly correct. So let us start with the minuend. 110110, that is 32 plus 16 plus 4 plus 2. That would be equal to 54. And the subtrahend 110011, that would be 32 plus 16 plus 2 and plus 1, that would be 51. Now 4 minus 1 is 3, 5 minus 5 is 0, and as you can see here, 1 is true for 2 plus 1, or rather 2 and 1, and 2 plus 1 is equal to 3. Alright, now that we've covered subtraction of binary numbers, let's shift our focus to another important operation, the multiplication of binary numbers. Daniela, are you ready to explore this with us?
Absolutely, Khayzee. I've been following along and I'm eager to dive into binary multiplication. Hi everyone, I'm Daniela. Today I'll be handling multiplication and division of binary numbers. The rules of multiplication are rather simple. In binary multiplication, you follow similar rules as in decimal multiplication. The binary multiplication operation is actually a process of addition and shifting operation. This process has to be continued until all the multiplier is done, and finally, the addition operation is made. Rules of multiplication. The multiplication of the binary numbers is done by multiplying the multiplicand with the multiplier. It is noted that the multiplication by 0 makes all the bits 0, and this step may be ignored in the intermediate steps. The multiplication by 1 makes all the multiplicand value unchanged.
Hello everyone, here we have Ahleah multiplying 1101 and 110. So first up, you must write the numbers vertically, lining up the rightmost digits, and then you multiply each digit in the bottom number by each digit in the top. So here we have 1 multiplied by 0, that's all zeros, and then you move to the second row, position to the left, and repeat. So 1 multiplied by 1011, that would be, you just copy 1011, and then you move to the next row to the left, and still it's 1 multiplied by 1011, and you still copy the top given. Now, here comes the addition operation. Apply all the knowledge you gain from the previous rules on addition and you'll get your answer in a short while. 1101 multiplied by 110, you'll get your answer, which is 1001110. Now let's do the checking to see if it really is correct. Let's start with the multiplicand, which is 1101. It is equal to 13, and with the multiplier 110, it is equals to 6. 13 multiplied by 6 is 78, and if we convert our product to decimal, 1001110, we'll get 64 plus 8 plus 4 plus 2, and if you add them all together, you got 78, which corresponds to the decimal one. Here is our second given. Sorry, it's still number 1, but it's actually the second one, the second given. So we'll be multiplying 101101 to 1101. Remember, if it's 1, you basically copy the whole given, the multiplicand, and then you move to the next row to the left. And then after you're all done, you will lastly perform the addition operation and see if and get your answer. Now we can finally do the checking for the multiplier, and the product. Starting from the right, 101101, that is equal to 32 plus 8 plus 4 plus 2. And as we all know, if you add all of those up, you get 45 in decimal. Now for the multiplier, 1101, starting from the right, that's 1 plus 4 plus 8, and if you add them all those up, you'll get 13. Now 45 multiplied by 13, you'd get 585. Now let's see if the product is correct for those numbers. Starting from the right, 1001 001001. So these powers of 2 will reach until 256 and 512, and these are true for 1, and that will be added to 8, added to 64, and will be lastly added to 512. If you mix all those up, you will get 585, which is true for binary and decimal. Here we have our second to the last item. Once again, if it is multiplied by 1, you basically copy the multiplicand, and as you move to the next digit, you move to the next row to the left. And if it's 0, you basically set the whole equation to 0, and now you do the addition operation. As soon as you finish adding everything, you may now do the checking to see if your answer really is correct. Now starting from the right, 1101, the multiplicand, it is equals to 11 because 8 plus 2 is 10 and plus 1, that's 11. The multiplier is 0111, and you'll be starting at the right. It's equal to 7 because 4 plus 2 is 6 plus 1 is 7. 11 multiplied by 7, you'll get 77. 1 multiplied by 7 is 7. 1 multiplied by 7 is 7. Now let's see if the product of our binary equation is correct. Starting from the right, 101101, which corresponds to 64 plus 8 plus 4 and plus 1. that is equals to 77, which makes our equation true for both binary and decimal. Now here we are at our final item for multiplication, 101 multiplied by 011. Okay, let us repeat this as much as we can. 1, if it's multiplied by 1, you just copy the multiplicand, and if it's 0, you basically set the multiplicand to 0, and then you add. For the multiplicand, 101 is equals to 5, 404. It's true for 4 and 1. The multiplier 011 is equals to 3, and if you multiply 5 and 3, you'll get 15. For the product, 4 ones, that corresponds to 8 plus 4 plus 2 plus 1. As we all know, 8 plus 4 is 12, plus 2 it's 14, plus 1 is 15. So this is true for both binary and decimal.
Division of binary numbers. Rules of division. 1 divided by 1 is equals to 1. 1 divided by 0 is meaningless. 0 divided by 1 is equals to 0. And 0 divided by 0 is also meaningless. Binary division is a mathematical operation performed on binary numbers, which are numbers expressed in the base of 2 numeral system. In binary division, you use the same principles as in decimal division but apply them to binary digits, which are zeros and ones.
Hello everyone, so this is our first given for division. It is 10 divided by 100, or in a decimal that would be 2 divided by 4. So starting from the left, compare the leftmost bits of the dividend with the divisor. Our divisor here would be 10 and our dividend will be 100. If the divisor is smaller or equal, subtract the divisor from the corresponding part of the bit. Write down the result 1 or 0 above the dividend. 1 is less than 10, so you don't have to put anything above 1. However, if you move to the right, 10 is equal to 10, so you put 1 above 0 in the second place to the right. Now you multiply 1 by 10, you'll get 10, and then you bring down the next bit of the dividend and subtract it. 0 minus 0 is 0, 1 minus 1 is 0. And then you bring down 0, and as you can see, it is unequal, so you put 0 on top of the dividend. You get the answer 10. Let's do the checking to see if this is really correct. 100 corresponds to 4, 10 corresponds to 2, and that makes it 2 divided by 4, which is 2. 4 minus 4 is 0. And it seems like our answer and checking is correct. Here is our second given. Once again, you align the divisor with the leftmost part of the dividend, just as you would in decimal division. And you start from the left, comparing the leftmost bits of the dividend with the divisor. If the divisor is smaller or equal, subtract the divisor from the corresponding part of the dividend. Write down the result, as you can see here, and bring down the next bit of the dividend and append it to the result from the previous step. If there are still bits in the dividend, repeat the process, bringing down the next bit and continuing the division. Here is our last given. 1 divided by 1 cannot be, so you move to the right. 1 divided by 1 is equal to, so you put 1 above 1 above the dividend, and then you multiply it and subtract 1 1 from 1 1. That is equal to 0. You bring down 0, 0, and 1 1 cannot be, so you put 0 above the dividend. Once again, 0, bring down 1. It cannot be, so you put another 0 or above the dividend, and then bring down 1. That is equal to 1 1. It is equals to 1 1, the divisor, so you put 1. 1 multiplied 1 1 is 1 1 minus 1 1, which is 0. Now let's go to the checking. Starting with the dividend, 11011, it is equals to 27, and 1 1 is equals to 3. If you divide 27 and 3, you get 9, and 9 multiplied by 3 is 27, which leaves 0. Our quotient, 1001, is equal to 9.